Good evening, my YouTube viewers. In this particular video, what we're going to do is we're going to measure pain scales before and after treatment to see what the pain is before treatment and then see what the pain is after treatment. And we're going to write a program in Python to do this. So in order to write the program, the first thing that we need to do is we need to import 3 libraries. So the first library that we're going to import is NumPy as NP, which is a numeric library and also creates NumPy arrays. And the second library that we're going to import is Pandas as PT, which is a data processing library, and it also creates data frames and series. And the third library that we're going to import is matplotlib.pyplot as PLT, and that is a visualization library. And now what we're going to do is we're going to simulate pain data for different patients. A 0 is no pain, and a 10 is severe pain. But before we do that, what we have to do is we have to set our seed. And the reason why we set the seed is because we make sure that every time we execute the program, the values are initialized the same. So you set your seed by typing np.random.seed and any number you want in between the brackets. The number of patients is 50. The conditions are going to be pre-treatment and post-treatment. So we're going to generate random pain scale scores for the patients. So pre-treatment scores equals np.random.randint brackets 3, 10, number of patients. So that's going to be the pain before the treatment. And then the pain post-treatment scores equals np.random.randint brackets 0, 6 and num patients. And so that's going to be pain scores after the treatment. So they're just going to assume that after the treatment, the pain is going to be less than it is before the treatment. So now we're going to use Pandas to create a data frame of the pre and post treatment. So pain data equals pd.dataframe brackets, curly brackets, patient, np.arrange brackets 1, num patients plus 1 brackets pre-treatment pre-treatment scores post-treatment post-treatment scores. And now we're going to melt the data frame for easier plotting. So pain data melted equals pd.melt brackets pain data ID bears equals patient bear name equals condition, value name equals pain score. So we're going to plot a bar chart of the mean pain scores by condition. So mean scores equals pain data melted dot group by brackets condition square brackets pain score dot mean. And now what we're going to do is we're going to create a bar chart to annotate the pain before treatment and after treatment. So plt.figure brackets fig size equals 6, 4, and then plt.bar brackets mean scores dot index, mean scores dot value, color equals blue, orange, alpha equals 0.7. And then plt.title is mean pain scores by condition. The Y label is mean pain score, and the grid is axis equals Y, line style equals dash, alpha equals 0.7. So we're going to annotate the bar values, and basically this is just a piece of code that puts the values on top of the bar. And then we're going to have plt.type layout and plt.show. So now what we're going to do is we're going to create a box plot to visualize distribution of pain scores by condition. So plt.figure brackets fig size equals 6, 4. Pain data melted dot box plot brackets by equals condition, comma, column equals pain score, comma, grid equals false, comma, patch artist equals true, comma, box props equals dict, brackets face color equals light blue. The title is Distribution of Pain Scores by Condition. There is no subtitle. The Y label is pain score, and the grid is axis equals Y, comma, line style equals dash, comma, alpha equals 7, the plt.type layout, and show. So now what we're going to do is we're going to show a bar plot, a bar graph, and a box plot. So this is your bar graph. The post-treatment has a mean of 2.7 and pre-treatment has a mean of 6.3. And if you remember when we set the post-treatment, the pre-treatment was 3 to 10 and the post-treatment was 0 to 6. So they're just working on the assumption that the pain after the treatment is going to be less than the pain before the treatment. And then now what we've done is we've created a box plot, and you can see that the post-treatment is less than the pre-treatment. But I personally like the bar plot better than the box plot. Me personal, that's my personal preference. So this is the conclusion of this video. The next video we'll be covering another non-parametric test. So I hope you decide to watch it.